Hello everyone. Today we are starting chapter 6, which is going to talk about some general facts about polygons. Okay, a polygon is any closed figure, so our figure, all of the sides actually connect to one another. Okay, the sides are all line segments, so there are no curves, and it doesn't cross over itself. So those are some key features of a polygon. Straight sides, all the sides connect, and it never crosses over itself. Okay, so we've got sides of a polygon where the sides meet as a vertex, and if I'm connecting two vertices that are not next to each other, it is a diagonal. Okay, we name our polygon by the number of sides. Okay, you need to know, I lost it, all of these. These are all important. You have to know the names of all of these figures. Okay, so if I have 3 sides, it's a triangle. We should already know that. 4 sides is a quadrilateral, 5 sides is a pentagon, 6 is a hexagon, 7 is a heptagon. Okay, sometimes you'll see septagon, but I'm going to use heptagon in here. 8 is an octagon, 9 sides is a nonagon. If we have 10 sides, we have a decagon. 12 sides is a dodecagon. Okay, anything else, if no matter how big or small, if it's not on this list, like let's say 11, we don't have a name for 11. If I'm going to look at 11, I'm going to write 11-gon. It's an 11gon. Or if I have 123 sides, then I'm going to have 123gon. Okay, so it is important that you know how to name polygons. Okay, so again, we're just counting the number of sides and then using our chart here. Okay, most of these should be familiar. This one and maybe this one are new. Okay, hopefully you should already know the others. If you do not, you need to get to know them quickly, please. Okay? So let's take a look at actually using this. So we're going to jump around a little bit in your notes because at the top you've got a lot of information. The examples are at the bottom. We're going to jump back and forth a little bit. So when we look here, we want to know, is the figure a polygon? And if so, how many sides does it have? And name it by its sides. Okay, so when we look at this one, it is all the sides are straight lines. Okay, they all connect. So this is a polygon. And it has 1, 2, 3, 4, 5 sides. A 5-sided polygon is a pentagon. Okay. When we look at B, notice that we're supposed to have this as one figure and it crosses over itself. The sides intersect. So this is not a polygon. Okay, this one, all of the sides are straight. They all connect. It got cut off a little bit here, but ignore that. They do connect. Okay, and none of the sides cross it. So this is a polygon, and it has 1, 2, 3, 4, 5, 6, 7, 8 sides, and they're not all equal. That was just me counting. Okay, so we've got 8 sides. So it is an octagon. All right. So any 8-sided polygon is an octagon. Next, we're going to talk about regular polygons, which is what you're going to tend to think about when you see an octagon. Like you would tend to think of a stop sign. If I say octagon, you think of a regular octagon. Any regular polygon is equilateral and equiangular. So all the sides are the same length. All the angles, the interior angles are the same degree. Okay, if it is not a regular polygon, it is called an irregular polygon. So all of these polygons here, the A and C, are not regular. Okay. The next part is, are they concave or convex? So a concave polygon, the way I think about it is that it caves in. Basically, you have one angle that is greater than 180 degrees in your polygon. So this side kind of caves in towards the middle. Convex is like you've blown out the balloon. There are no sides that come in. Everything kind of pops out. So that's the difference between concave and convex. And again, we kind of jump back up in your notes a little bit for this. But so the big key things here. So far we've talked about what is a polygon, how to name them, okay, what a regular polygon is, and whether it is concave or convex. All right, so it's a lot of information real quick, so you got to kind of stay with me and stay on top of it. So we want to know whether the polygon is regular or irregular, concave or convex. So the first thing we look at here, we have a rectangle, okay? All 4 angles are the same, so it is equiangular, okay? But is it equilateral? Is this side the same length as this side? And that answer is no. These are 2 different side lengths. So because the side lengths are different, it cannot be regular. So it is irregular. Okay, concave or convex, everything pops out, nothing cuts in anywhere, so it is convex. All right, when we look here, I've got a 6-sided hexagon. Notice that all of the sides are the same length, and all of the interior angles are the same degree. So because it is equilateral and equiangular, it is regular. All right, nothing kind of comes in. None of those angles are greater than 180, so it is convex. A regular polygon is always convex, okay? A regular polygon is always convex, and that actually says that right here. Okay, that's something that is important for you to realize. Regular is always convex, okay? So let's take a look at this one. A lot of people at first want to say regular here because we see that it is equilateral, and I see that these 4 angles are congruent. But how many angles are actually in this figure? Okay, there are 8. This angle here is not the same degree as this angle here. Okay, these are very different. So because of that, it is not regular, it is irregular. Okay, and this angle here is going to be more than 180, so it is concave. So this side kind of caves in towards the middle. This caves in towards the middle. That's how I just kind of tell the difference between them, and that's easy for me. All right, so let's go ahead and turn the page in your notes. And again, we did do this in class, so if you have questions, just kind of make notes on the side if you were absent, and then we will go over them when you get back to class. All right, the next thing that we're going to look at is finding the sums of the angles in a polygon. Okay, so I want to know how I can find the sum of the interior angles. Okay, this formula right here is going to be one that you need to know. Okay, it is very important. You need to know this formula. It is n minus 2 times 180, where n is your number of sides. So let's think about how this works for a second. Now, you just have this chart on your notes. You don't have the things on the bottom, and that's okay, because I'm going to talk through this. So if I have a triangle, we know that a triangle has 180 degrees in it. So every triangle is 180. So what I'm going to do is if I get another side here, I'm going to go from a diagonal, and I'm going to see how many triangles I can make just from one vertex. All right, so if I start here, I can draw one diagonal. So I have 2 triangles. So each one of these is going to be 180 degrees. So it's 2 times 180. All right, with a pentagon, same thing. I'm going to go here, and I can cut it into 3 triangles. Each triangle measures 180 degrees. Okay, same thing with our hexagon. Okay, we can cut it into 4 triangles, and each triangle is 180 degrees. Well, how many triangles do I have here? I have 1 triangle. I have 2 triangles, 3 and 4. How do I get that? Well, if I have 3 sides, okay, and I subtract 2, I get 1. If I have 4 sides and I subtract 2, I get 2. If I have 5 sides and I subtract 2, I get 3. If I have 6 sides and I subtract 2, I get 4. So that is where this n minus 2 comes in, because that's the number of triangles that you can divide your figure into. Okay, and then we multiply it times 180 because that's how many degrees are in each triangle. Notice that this only works for convex polygons. Okay, so a triangle, we do n minus 2, which is 1, times 180. 4 minus 2 is 2, times 180 is 360. Pentagon, 5 minus 2 is 3. 3 times 180 is 540. So this is how we get our formula. This is where the formula comes from. It's just how many triangles, what is the fewest number of triangles that you can divide your shape into. Okay, that's what we're looking at. So that is where our formula comes from. You need to know this formula. Okay, so the big things that you need to know so far from this lesson, you need to know the number of sides and the names of each figure. You need to know what is a regular polygon, what is concave and convex, okay, and whether or not a figure is a polygon. So that's where we're at so far. So let's take a look at actually applying this information here. Okay, I want to find the sum of the interior angle measures of a convex octagon. So again, the key words here are interior angles, okay, convex octagon. So, and sum. I want to find the sum. Okay, so if I'm finding the sum, my formula is n minus 2 times 180. All right. Now, a convex octagon. An octagon has 8 sides. So I'm going to do 8 minus 2 times 180. 8 minus 2 is 6. So I'm going to do 6 times 180, which is going to give me 1,080 degrees. So the sum of the angle measures of the interior angle measures of a convex octagon is 1,080 degrees. All right. Now, let's take a look at C. Okay, I want the measure of each interior angle. So a kind of key part here is each. All right, and another key part is we're looking at a regular nonagon. Again, another kind of important part of the importance is the regular. Okay, a nonagon has 9 sides. So a couple of ways we can do this. So let's start by finding the total number of degrees. So it's n minus 2 times 180. I have 9 sides, so it's going to be 9 minus 2 times 180. 9 minus 2 is 7, so 7 times 180, which is going to give me 1260. Okay, so 1,260 degrees in a nonagon. If it is regular, that means every angle measure is the same. All right, so I can take that 1260 and divide it by the number of angles. The number of angles is going to be the same as the number of sides, and that's going to give me 140 degrees. So what I can use is when I'm finding each interior angle and my figure is regular, I can do n minus 2 times 180 divided by n. That was a weird n. Okay, so n minus 2 times 180 divided by n, this gives me each angle. Okay, but the key here is it does have to be regular. All right. Let's take a look at part C. Okay, I'm given a figure and I'm given expressions for each angle measure. So the first thing I need to do when I have a problem like this is I want to figure out how many total degrees are in my figure. Okay, now it's a quadrilateral, so you may already be able to jump to, oh, I know that it has 360. Okay, if you cannot jump there, and with some of the more frequent ones, you will start just naturally memorizing how many degrees are in them. We start with, okay, I know I have 4 sides, so I'm going to do 4 minus 2 times 180, and that's going to give me 360 degrees. So there are 360 degrees in my figure. So now what I'm going to do is I'm going to add up all the angles and set them equal to 360. So I'm going to do C plus 3C plus C plus 3C equals 360. Now, a little tip for you guys is I pick an angle to start with, and I go around in a circle around my figure. So C, 3C, C, 3C. And that way you don't miss anything. It's not that big of a deal when you have a smaller figure, but if you start getting like an octagon or a nonagon, something that has more sides and more angles, it can be easy to miss one if you're kind of jumping around. So if you start at one angle and kind of go around in a circle listing those angle measures, it tends to be just a little bit easier. So this is going to give me that 8C is equal to 360. And when I divide by 8, I'm going to get C is 45. Okay, so the measure of angle P and the measure of angle R are both C, so I know that they're going to measure 45 degrees. All right, 3C is going to be 3 times 45, which is going to be 135 degrees. So that means that the measure of angle S and the measure of angle Q are 135 degrees. So that is the answer to my question. Okay? So again, there's a lot of information in this one section and we're still not done. So just make sure that you're taking your time with this, you're watching it back again, and really make sure that you are understanding each part because it is a long lesson. All right, guys. So there's our interior angle measures. We found the sum, we found one, and we found each one when it's not regular, okay? And we had expressions. So now let's take a look at what happens when we have exterior angles. Okay, our exterior angle measures, remember if we had a triangle, remember this was our exterior angle right here. I can have an exterior angle at each vertex. Okay, so these are all exterior angles here and here. So anytime you're extending the side of a polygon, you're going to get exterior angles. So we want one at each vertex, okay? No matter the shape, no matter how many sides, as long as it is convex, my exterior angles are always going to add to 360, no matter what. All right? If my polygon is regular, I can do 360 divided by n. To get one exterior angle. So this is 1. And again, it has to be a regular polygon. Handwriting is not the best today, guys. Sorry. All right. So, any questions on this? Again, write it down and take note of it, and we'll deal with it when you get back to school. Okay, so here we want to find exterior angles in polygons. So again, let's look at our keywords. We're looking at each exterior angle of a regular hexagon. Okay, so again, each and regular are extra keywords here. So we're looking at exterior angles of a regular hexagon. A hexagon has 6 sides. So I know that my total degrees in my exterior angles is always 360, no matter what. So if I divide 360 by n, I'm going to get the number of degrees at each angle. So 360 divided by 6 is going to give me 60 degrees. Okay. Looking at part B here, we have exterior angles, 1 at each vertex. All right. And again, exterior angles, no matter what, are going to add to 360. So pick a place to start. It doesn't matter what vertex you start at. It doesn't matter which direction you go. Okay. But pick a place to start and go around the circle. Okay. I'm going to start with 7A. I'm going to do plus 2A, plus 3A, plus 6A, plus 2A. That's going to equal 360. Okay, so each of these, I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so you just might want to double check things like that just to make sure that you haven't accidentally missed an angle. All right, so I'm going to combine like terms here and I'm going to get 20A is equal to 360. So A is equal to 18. That is all that I wanted here was the value of A. If I wanted each angle measure, then I would turn around and plug A back in. All right. All right, next one here, let's move on along. These are kind of working a little bit backwards. All right, so we've got, okay, I have a polygon that has a sum of 900 degrees. I want to know how many sides it has. So let's take a look at our polygon, our interior angles, okay? We know this is interior because exteriors add to 360. Okay, so it doesn't really have to say that this is interior, though it kind of should. But we know that if it's anything that's not 360, it has to be interior angles because exterior is only out of 360. So our interior angle formula is n minus 2 times 180. So we know that when we do that, we're going to get 900 degrees. Now, there's a couple of ways that we can do this. I can distribute the 180, subtract, and divide, but the easiest way to do this is to start by dividing both sides by 180. It makes your number small very quickly. So we're going to be left with n minus 2 is equal to 5. Add 2 to both sides, I get n is 7. So I have a heptagon with 7 sides. Okay. And then the same thing here, we've got an exterior angle. So an exterior angle of a regular polygon measures 24 degrees. So this is an exterior. Okay, and it is regular. We want to know how many sides does it have and what's the measure of the interior angle. All right, so let's start with our exterior. I know that 360 divided by my number of sides is going to give me 24 degrees. So I'm going to cross multiply here. I'm going to get 360 equals 24n. Divide both sides by 24. I'm going to end up with 360 divided by 24 equals n. All right, and this is going to give me 15. So it is going to have 15 sides. All right, so I have a 15 gone. Okay, now to get the measure of the interior angle, we can do this one of two ways. We can know that if I have an exterior angle that measures 24, remember guys, if we're looking at a polygon here, I'm just going to draw, whatever, I'll just draw a quadrilateral. Okay, here's my exterior angle here. What do we know about these two angles? Okay, they are a linear pair, so they add to 180. So the interior angle is just going to be 180 minus 24. So my interior angle is going to measure 156 degrees. Okay, do it the easy way. The other way that we could set this up is to say, okay, my formula is n minus 2 times 180, and I divide that by n, or excuse me. So we're going to, and so here we go. So we're doing n minus 2 times 180, divide that by n. All right, well, we just found that we had a 15 gone, so we're going to do 15 minus 2 times 180, divide that by 15, and that will give us 156 when we put that all in the calculator, okay? So does that make sense? You can do it either way. It's not a problem. A lot of times, if they try to give you the interior angle, it's almost easier to find the exterior and just go from there with number of sides rather than going through this. So like if I said I had an interior angle that was 156 degrees, what's my number of sides? Well, I could set this equal to 156, which is complicated. Or I say, okay, if I know I have an exterior angle that's 156, then my interior has to be 24. And then I do 360 basically divided by 24. And it's a lot simpler to go this way. So I want you to see the relationship here between the interior and the exterior angle, that they are supplementary. They do add to 180. That way you can make sure that everything is good. All right. So I'm going to go ahead and close this out. If you are homesick and you're watching this, or you're just watching this to get a second viewing of it, make sure you are looking at eCampus for the homework. All right. I will see you guys later. Have a wonderful day.